Later, can you also join the meeting and present? Because people we need to record. Yeah, you should be able to join the meeting. Okay, so let's get started. So yeah, first I need to apologize that there are some delay for me to prepare the reading list. For the first two lecture, I assume you don't have to sign up. I already asked my students to sign up for those lectures. You can sign up the lecture from the third one, which is on February 16th. So as I mentioned earlier in the team channel, let me check team channel, where to access it. Oh, not this one. Okay, so here, at least some rules, right? So each of you need to sign up as presenter at least once and as reviewer twice. If you are not sure what's the role of presenter and reviewer, you can go to the slides of first lecture. It should be also on e-learning. So the first lecture slides. Yeah, I should already mention what is the role of reviewer or presenter, right? Oh, this is about the project. Reviewer, presenter, where I mentioned that? Oh, here. Right, presenter need to submit your slides 3 days before the presentation. So which means if you're going to present February 16, you need to send me your slides on February 13, okay? And for reviewer, you need to answer questions on students, right? Student need to submit the question 1 day before class. So how you submit question is that I'm going to create a channel here. Question and answer. Okay. And what I'm going to do is to create a thread for each. So how about you guys can create your own thread, but let me just use this lecture, next lecture as an example. All right, so this will be the paper to present. Copy here. And then you just ask question here, right? So I should be able to see who asked question, then I just check your name, right? See, saying you already asked a question here. Yes. Say that again? Oh, you cannot see anything here? I thought I duplicate my screen, right? Wait, let me duplicate my screen. Okay, so yeah, I just posted here, right? Okay. Then you may miss a lot of content, but it should be in the recording, but I can go over it again, right? So check the slides of first lecture. It's on e-learning now, right? You need to submit your question 1 day before class. So presenter need to submit your slides 3 days before class, okay? So for example, for this one, need to submit on February 13. And your presenter need to meet ahead, right? So I'm going to set the deadline for sign up on Monday next week. Let me add everyone. Sorry, I'm using Chinese here. Please sign up by the end of Monday next week, which is when? Monday next week, February 5th. Okay. Then after you sign up, you should meet with each other and discuss how to present the whole topic, right? So for some of the topic, I attach some extended readings, some surveys, some I haven't, but I can attach some later if needed. And for presenter, you meet together and figure out how to present. Of course, you need to read paper ahead. For people who serve as like if you are not a presenter or reviewer, you need to ask question here, okay? If you are a reviewer, you need to answer all the questions that people put it here, right? So that's the thing. What else? Yeah, I can briefly go over the topic here. So today's topic will be an extension for what I have presented last time, mainly about some of the work we have done in our group. And then LLM planning, Zihe will present the next time. Combination of some work we have done and other related work. And then we'll begin to first go over some background knowledge, training, right? So for training, the first focus is on the scaling law, and then we'll talk about in-context learning, which is, for example, like a few shot learning, right? Give some few shot example, something like that. But what we are focusing on is more on why few shot prompts works, right? Why in-context learning works. Well, trying to understand the internal mechanism behind why these things works, right? And then fine tuning, we will talk about LoRa, and some classic papers, right? Like Laura, right? How you do fine tuning. The reason why we talk about fine tuning is because later on we'll talk about, like here, distributed fine tuning, right? Like this paper I recommend you to read Git Theater, which is like to say you have distributed fine tuning, how you merge the model together to become have a just like develop open source software, how you can contribute to make the model better altogether. After fine tuning, we will talk about some system side of training. So here, one of the focus here will be decentralized training or distributed training. This is one of the represented paper here. And the other is like some tricks that will make the training better, faster, right? So we'll talk about flash attention here. Well, this topic is somehow related to here we'll talk about sparsity and training. So those are some papers that help training, but more on sparsity perspective, right? But as you know, like flash attention is not on sparsity, but more on optimization on I/O, right? Excuse me. How you decrease the read and writes on memory, on the slower memory, right? Like, but use more on SRAM and cache for those read and writes, right? So the essential idea is they make things in block, right? And do tiling, right? If you have studied compiler before, it's called the tiling technique, right? And then after spring break, we'll not do it in lecture. We'll probably schedule another time, right? Outside lecture to do midterm presentation. So I'll probably take a day to go through your midterm presentation. The goal here is just to fix whatever issue that you might have so that you will have successful final project, all right? So, but I also specify on the slides that what you need to deliver midterm, right? So I think midterm, right? It's including all the proposal stuff and problem definition and the example. So that's midterm. And then we talk about AI ops, right? So here I put a lot of focus on this distributed fine tuning. To read this viewpoint paper, but also there are some other perspective of AI ops. I probably can briefly introduce on this as well. And pruning quantization. So remember, I put some survey here. You don't need to present a survey, but you can reuse some of the motivation, introduction, or figure in the survey to present a whole topic, right? So remember, you need to present a whole topic instead of just presenting individual paper, right? So I actually mentioned. So that's a common pitfall, right? So that's also why I ask you to send a presentation 3 days before. Because the key here is to present it as an inherent topic, not as an individual paper, okay? If you fail to do that, definitely I'll give you the comments and you need to probably prepare your presentation all over again. So this survey paper sometimes it just help you to know the big scope of the paper of the topic, right? And after pruning and quantization, we talk about sparsity using 2 lectures. One lecture talk about inference, one lecture talk about training. And then we talk about some recent development on new model architecture. Because as we mentioned, right, the attention-based neural network, they have a quadratic performance, right? A quadratic complexity compared to the length of the sequence. If we want to longer sequence, we probably need to go beyond the attention. So this is where we talk about beyond the attention. And last, we talk something about compiler, mainly on TVN and Tensor IR. So I also collect some paper about adversarial attack, but these are relatively older topics, so we probably won't discuss it in this class anymore. But if you are interested, you can still take a look, right? Because for this attack, there are thousands of papers, right? So it's a crowded area, so I wouldn't strongly suggest not to pick one of those as your research topic. Quite competitive, but all these are quite some recent development, right? Starting from here, right? Starting after midterm, those are recent development, which, I mean, pruning and quantization also very crowded, but there's still some work you can do. Okay, so that's roughly the timeline. Any question? Yeah. Yeah. So these papers are just something that I require you to cover, right? More or less, right? You can cover less, you can cover more, right? But you don't have to go into tiny little bit detail in your presentation, but you should know how things work, right? And also that's why we split your presentation into two halves, because probably in the first half of presentation, you are not be able to understand all the detail, but after Q&A, you take those questions back, and then next week you come back to present details so that you can answer questions. And also you can add your own work understanding, right? So that's actually a bonus, right? Because you do beyond what's offered here. So that's actually good, right? Any other question? Yes. 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 So as already mentioned here, right? For topics with 3 papers, at most 2 students can sign up. For topics with more than 3 papers, we allow up 3 students to sign up, right? So it's first come, first serve, okay? Because I can read the history here, okay? So I can see whose name was put it first, whose name was put it later, right? So if you try to override some other people's name, I can see it, okay? So you can sign up, right? And if you see already 2 students sign up for the topic with 3 papers, don't add your name to it, okay? Because otherwise we will end up with some topic with only 1 student, right? So we want to avoid that, right? Like for those topics which are a bunch of paper, you can have 3, right? This also can have 3. And pretty much all this, some of topic you can have 3, some topic you can only have 2. So it depends on what you have. But if you have a special request, you say, okay, I know some paper that can add it to this topic, and I see 2 people already registered to topic, but I can add my name, but contribute to more papers on it. You can let me know, right? Send me a message or email. We can adjust that. Otherwise, for example, I can see, right, there will be more training system infrastructure on distributed training. Then we can allow 3 presenters on this topic. Well, given a condition that you add more papers to it. Okay. So, and for reviewer, we allow 6 reviewers per topic. Okay. You need to review twice. Okay. You need to review twice. So you can sign up for a reviewer here. Okay. So that we have enough people that have knowledge on the paper, so that we hopefully we can initiate some discussion, right? Because I suppose if you're not a reviewer, you're probably not reading into detail, right? But if you're a reviewer, you need to answer questions, and you need to read into detail. Okay. Other question? Okay, then I'll take a brief moment to introduce some project ideas. So notice that you should come up project ideas through the readings here, okay? There will be more ideas here than what I presented. What I presented can be as a reference, okay? So the first idea I'm going to talk about is some work that we will be discussing in next lecture. So it's centered around like building a runtime system for LLM, right? So in this idea, right? So you know LLM, we talk about it cannot handle very long sequence, but it's essential for some tasks to have longer context, longer sequence, to handle those tasks. Yes. Oh, okay. So let me see what I should do. Need to adjust the screen setting again. Okay, so we can handle those tasks, right? So enabling LLM with certain capability to handle that task which require a longer context, right? So this is a screenshot of one of my paper that we use LLM to handle UI navigation task on mobile phone, right? So the goal here, what we're trying to do is actually just create an advanced theory, right? So the current theory only you can send some instruction to perform some system level operation. What we want to do is that Siri can have the capability to do everything on every app, right? So if you write a third-party app on yourself, you can ask Siri to perform some action on that app, right? So in that sense, Siri needs some understanding through the user interface. You need to understand what functionality this app has and how can it interact with the application so it can perform certain operation, right? So this is what we're trying to do here. And we have, because it requires a lot of contextual information, and it also requires some domain knowledge for example, in this case, UI exploration. So we have several parts like memory, execution engine, and knowledge loader. So essentially, you are building a runtime system for LLM, right? It's kind of operation system. You get memory management, have a driver, right? For driver to do stuff, and you have a knowledge loader to load things. So although we have already have an initial paper on this, there are many things that you can do based on this topic, right? So one of the things is that adaptive memory management for this runtime system, right? So because so this kind of like you probably have some experience when you use ChatGPT, right? You have a lot of historical context. You are performing a task. You have hundreds of rounds of conversation with ChatGPT. Some of the historical context could be used for later conversation, later task, right? So then how you can do this optimization, storage, and retrieval of those historical contexts so that you'll be able to efficiently communicate with LLM about your task, and then also can provide most related information to LLM to perform that task, right? So that's one of the topic. And the second topic is how you load domain knowledge, right? So we know LLM may not be able to handle everything, right? One of the things that people do is to do fine tuning, but that's very costly. Right? You need to create a huge layer, right? It's called LoRa, right? We'll discuss that later. Suppose you use LoRa to do fine tuning. Still require a lot of efforts, and you still need a lot of training data to do so. But for a lot of domain, they already have some heuristic and rules that they summarized so that they can guide the LM to follow those rules without providing actual training data. So here is just like how you incorporate those domain knowledge, those rules, and to guide the LM to perform a certain task. So loading domain knowledge into runtime system, right, to perform this kind of task. So that's a second idea. Any question so far about this runtime system for LLM? Because I suppose for some of you, it could be a not very familiar topic. But anyway, just incorporating rules, heuristic into LLM. And third idea is something we have already been working on, is optimization in action space for LLM. So basically, if for example, in the context of planning task, you require LLM to give you some guidance into what's the next action I should perform. Sometimes LLM give you wrong action, but you know some of the action definitely is not in the candidate. You can prune it yourself, right? Using some like domain knowledge, as I said, or using some like feedback that LLM itself gave, right? Like in our UI exploration, we have the case, right? LLM expect the next screen would show up certain button or certain user interface, but actually the environment, the next screen wouldn't give you that information. So the environment actually provides unexpected information to LLM. So it deviates from the LLM's original planning. So here, then you can do some optimization based on the reflection that LLM itself can have, right? So some reflection and a lot of technique has been working on that, right? Like chain of thought, tree of thought, all these kinds of things. So that's one of the direction you can perform, right? So if you have unexpected scenario that deviates from LLM's original planning, what you should do, right? And then it's about replanning, right? Whenever the original planning doesn't work, you want to think about replanning. But how you perform this replanning? Some of the tasks is simply it's not very easy for you to go back. It's not very easy for you to do like depth first search style of planning because is essentially you cannot go back to the upper level and do planning again, right? So for example, you are in certain navigation tasks, you are in a maze, you're already lost, and you don't know which path you have taken earlier, right? It's very difficult for you to go back. And for example, in our UI screen scenario, right, you submit certain ticket, right? Let's say in UTD, some register system. It's not very easy for you to go back to the previous state because some persistent state already changed. So in that sense, how you plan, how you do replanning, right? Because here depth first search that doesn't work, right? So now how you use LLM, incorporate LLM to perform those tasks. And like all other systems, this runtime system require error handling and recovery. And here, basically, you can just observe what kind of common error that require special handling and design some this error handling and recovery mechanism for this system. It's just kind of like in all kinds of programming language, you need to have this error handling and recovery to catch the exception, right? So that it wouldn't break all the system, all the whole system. So in LLM, things like that would also happen. So how you catch those errors and do some special handling would also be a topic. So this idea is related to the driver in earlier slides. So in earlier slides, we talk about driver, right? We have two driver, LLM driver, and this UI driver can be any other downstream task driver. So the things here is that how you interpret the LLM's answer into some actionable items or some actions that you can actually perform on things you want to do, right? So if you want guide the robot to do some task, so what LLM's output may not be comprehensible to robot, right? So you need to do some translation, and in that sense, there could be some domain gap between what LLM understand what it can do and what it actually can do, right? So how you fill in this gap and make the system perform such response. So in here, again, you need to introduce some context, right? So that also comes to the earlier problem that context is not long enough. We don't have enough context for LM to understand everything. So how we can make the context long enough? How can on the system level how we resolve this issue, right? But here is on the more from the software engineering level or software level, how we, given that the system only support this such long context, how we use a software layer to alleviate the issue that it may not be able to understand certain things fully because of the limited length on the context. And how we incorporate the context to do some pre-processing, post-processing to make the job better done. And here would be yeah, more related to like, again, on the driver. It just potentially you could have some human operator on certain things. You know, how you make it more smoothly for human, right? And also it's more of like similar to the previous idea, how you make the interaction between the downstream task driver and the LLM's response to be more coherent, right? It's just here the downstream task driver can probably involve more on human. So how you can leverage human interaction more, right? Like maybe more let LLM ask question to human, what kind of information they need, right, to assist the performance of this task. So instead of giving a poor result, he can actively seek more information from user to achieve better result. So this is something, yes. Yeah, so we have some existing system on UI exploration task. It's quite simple, just a few hundred lines of code. If you want to develop it for other tasks, it's also, you just follow the same style. Or you can just reuse whatever we have developed and add more things on top of it. So the choice is yours. But we can just give you the code and you can just say, okay, how we develop this, right? It looks like a lot, right? But this, like LLM, you just interact with natural language token, right? It's not that a lot, right? So it's very easy to develop all these things. The good thing on development on LLM is like engineering effort is minimal, unless you are developing things like I will mentioning later, right? Like optimization, sparsity, all these things, which may require some code writing. Yeah, but for this one, I can give you a system to work on, right? Yeah, for each idea you have, right? If certain resource, you should let me know, right? Send an email or send a message to me. You should let me know. Okay, the second project idea is centered around this Git theater. So which is also on one of the AI ops lecture, right? We'll talk about this paper and things. So the conceptual idea here is just want to build machine learning system more like open source software. So let me open this paper so I can better explain to you what I mean. Uh, I mean, stop presenting. Okay, response. Okay, now it's here. Just need to find my mouse here. Okay, so this viewpoint paper on CSCM, it just say, want to build machine learning model more like open source software. All right, so how we do build that, right? How's the open source software built? So usually the way they build is through GitHub, right? So let me open the link of this Git theater paper by just searching for this paper. Right, so we built it through GitHub, right? Like something like that. So the aim of this project, this conceptual idea is that, okay, you have a foundation model. We talk about foundation model in first and second lecture. So the foundation model will serve for some downstream tasks through fine tuning. Then how about we all contribute to that task? Okay, you can fine tune certain part of model. I can also fine tune certain part of model. And eventually we can merge our contribution together to make this foundational model better, right? For example, I fix some security or privacy issue of this foundational model. And what you do is to make this foundation model more suited for like robotic task. How can I merge these two features together so I can have a safe model that can also perform robotic task? So it's just like you perform this model or develop this model or improve this model like an open source community. So then back to this Git theater, which is they have a Git extension so that you can collaboratively develop the model or fine tune the model. So based on this idea, there are many things you can do, right? First is that something we also will talk about is distributed learning, right? Like how you can on different machine on different places you can incrementally update the model, make it similar to like adding more commits, pull requests on your GitHub repository, so that your model would merge together. We'll talk about some of the paper in that lecture in this AI Ops lecture. So it's called AI Ops, but it's essentially a lot of paper is on that. But if you're interested in this project, I can send you even some more papers, right? Talk about model merging and other things. And you can also have model versioning, right? It's just kind of a GitHub management. You have a version control, right? And this also like you can also develop like a CI system for model, right? Like continuous integration, right? Let's say we develop a CI system for a model, right? And then you can even incorporate it onto Hugging Face or something like that. How can we distributedly, universally contribute to the model development? So this is something that's still lacking. Right? If you go to Hugging Face, all these things, you just a single author replacing different version of a single model. Right? It's just like a fine-tuned version of another model. You need to create another repo and upload that model. Right? It doesn't belong to any branch of the original foundational model. Right? But that's not supposedly not how things work. Because this is more of like in the old days where we update our course project report, the first version have a prefix or postfix like V1 and then V2, V3, right? It's just not smart, not how computer scientists should do things, right? But this kind of now model fine-tuning, model updating is like that. You just have another copy override the previous copy, right? You don't have version controlling. You don't have this merging, pull requests, all these things. So how we can make model development like that is some topic we can investigate. Okay, so after this, then yeah, like I said, right, testing and integration. Can you have the CI system, CI/CD system, right? So that for each commit, you will have a regression test suite to run through the model so that, okay, past this test suite, we can deploy the model on the system. Something like that, right? It's just continuous integration. If you have worked in the industry before, you know that, right? So every time you commit your code into your company's repository, you need to go through this CI system. Right? But for model development, which is the core of many products in industry, we still don't have that, right? How we develop CI systems so that people can use to manage their product development is something that we can focus on. I mean, this potential impact for this project can be huge, right? You can just build a CI system and all the company can use your system, right? Imagine that, right? So the potential impact could be huge in that sense. And I believe many companies may also working on that. For example, Hugging Face They should work on things like that. Also, GitHub, I think they probably want to work on that, but I'm not sure if they are ongoing efforts. Hugging Face, I know for sure they want something like that, right? Because come on, nowadays all the important products are based on the model. You see, like if you visit Google, right, see their code repository. Every time they submit a commit, they will run thousands of tests on their CI system so that they make sure this commit wouldn't break the things already in their system. But we don't have that for the models. What if, like, for example, ChatGPT commit a new version of the model and it breaks everything, right? It could happen. But there's just no safeguard for that. Right now, they just do manual testing to test out all these things. Yes. There are many things, right? For example, one of the most important thing they care is will they violate any laws and policies, right? There are a bunch of laws and policies say this AIGC product cannot generate certain things like violent, like malicious, right? If you terrorists want to use this kind of tool to generate a meticulous plan to attack certain place, you cannot allow them to do that, right? So all these kinds of safeguard. So I think they have a team to try to manually come up with different tries to make sure this wouldn't happen, at least wouldn't easily happen. Probably you need to do a little bit hacking to make that happen, but it wouldn't easily happen. Second?
So these tests that we write, we write those and develop those tests in software 1.0 and not software. How is it fundamentally different than writing tests for like software 1.0?
So in software 1.0, when you do automatic test generation, usually you look at conditional statement, you look at program path, right? So for example, I have a conditional statement. If A larger than 0, I do something. Then when I generate tests, I generate an A larger than 0. I also generate an A smaller than 0. Just make sure both branch will be safe, right? Now I'm good, right? But of course, you have thousands of conditions. So then you need to generate thousands of different inputs to make sure every program path is covered, is safe. But in machine learning model, you don't have that. You don't know which input will trigger new behavior, which input just trigger the same old behavior that's already been triggered by previous input. So this then becomes a new topic in terms of how you make sure you have a comprehensive test suite so that the model behavior is thoroughly tested. So I think that's a major difference because the traditional program is symbolic. It's very easy to make sure that it's fully covered. But you know, for all input larger than 0, it should have same behavior because it trigger exactly same lines of code. But here it's different, right? Because you don't know which input trigger same behavior, which input trigger different behavior. Yes. Yeah, for testing it's white box. You know the parameters, you know the model architectures, you know everything in the system. But you just need to come up with the cases where possibly could cause system fail. Or you can say I pass a set of cases, then I have very high confidence my system wouldn't break easily, right? There's no guarantee that our system will never break, right? Even in traditional software testing, we cannot do that. But you won't break easily, right? You wouldn't have situation like if a small kid is trying to use the system, it will give something that's not appropriate for the kids, right? So you want to prevent those things from happening. Right, like a bias detection, right? So something like it wouldn't discriminate against people, right? Say something that's inappropriate, right? This could be disaster for company's image, right? Things like that. Okay, then third would of course be security, trustworthy. As I already mentioned, I attached some papers on the bottom of the reading list, but I just don't think we have time to go through them. But these are some indeed security risks, right? For example, people can poison your data, right? So for example, so there are a lot of training data is from open domain. People can go to that open domain, purchase those domain, and purposefully poison the data to make your model less secure, right? Or your privacy, you may reveal certain training data to users, right? But you actually you shouldn't, right? You shouldn't reveal those training data. So how to prevent that? So this relates to trustworthy and security. Okay, so that's about the some project idea on the AI ops side. And then there are some other idea about compiler, which is more advanced topic. For those who are more interested on the system side, can choose this topic. So first, there are multiple deep learning compiler these days. And yeah, we mainly work on TVM, but all these are open source, which you can play around it. They also have a strong community support, which can pretty much resolve every issue you face. So one of the issue is that when we use deep learning model, usually they deal with floating point. Okay, if you learn a little bit about computer architecture, you know that computer cannot represent floating point number precisely, right? We just give a approximation of the floating point number we want to present, right? So then the issue would be there's a lot of optimization in deep learning compiler around the floating point computation. Each of these optimization would introduce certain precision loss. Not much, maybe eventually it won't affect the result, but what if it could affect the results, right? Usually the imprecision is like after like 0.0001, right? Some imprecision like that. But things could just be amplified, right? If you have so many layers of imprecision, maybe it will amplify eventually. So one of the things that trying to find if after certain optimization, the compiler could result in actually, for example, correctly classification is just make it to be incorrectly classified, right? So whether this optimization would change the prediction results. And the second is that how can we set a standard or certain way of optimization, certain step of optimization or certain pattern of the optimization so that you can constrain this error within a certain bound, which means no matter how you optimize, the error is always within certain bound. So I'll give you some example just to give you a rough understanding about what I'm going to say, right? So here, 1/3 is a floating point number where computer cannot precisely represent. So when you do 1/3 multiply 3, first you do 1/3, you get a number, and then multiply 3. You won't get 1, right? You will get 0.99999 because some precision loss in this step, right? Because the result produced by this step cannot be precisely represented. And because the neural network are very deep, so this error, this imprecision can be accumulated and amplified in the process. So what we're trying to do is to say, no matter how you do this kind of floating point operation, this kind of optimization, the difference between your final output and the original supposed output would always be within certain bound for all input here, right? So we want to certify the optimization in the deep learning compiler to say using this compiler wouldn't affect the accuracy of the deep learning model. Okay, the third idea will be also related to this. Given that we know there will be some accuracy loss in a compiler optimization. But how about we consider that in our training process? So for two purposes. One is that you don't have to be so precise when in training because the accuracy or the precision of each number will anyway be lost in later computation, right? It will anyway be lost in the optimization of compiler. So if you spend so many computation resources to care about the precision after 0.0001, it may not be necessary, right? So then this contributes to efficiency. Our result is the same after compilation. The second is about how you make it more error tolerant. Your resiliency against those potential imprecision, how you incorporate that into training process. Maybe you can add some noise in the training process already, so that even introduce some imprecision in the compiling phase wouldn't affect your final result too much. So you think about some regularization, so that the resiliency of your model can be improved. All right, so this that's pretty much just some idea about compilation. And here is again some more of like application idea is there's some this framework called the LoRa exchange. This is LoRa X. So you can visit this page. Oops. They have talked about, okay, I want to train multiple fine-tuned model. And I have a foundational model on a single foundation models. So the business model here works like this. I'm a company offer all kinds of service for customer, relying on one foundation model I train. Like for example, I'm a consulting company, right? Like I say Deloitte, Accenture, all this kind of thing. Each customer, they have their own need. They want to use their own data to fine tune the model to adapt to their need. So I need to train a lot of this fine-tuned version of my foundation model, which are very expensive, right? Each customer I need to train one. So what is LoRa X mean is that we want to productionizing many fine-tuned model together with a shared set of GPU resource, so that I fine-tune one for one customer. Some of the computation can be reused when I do fine-tune for another customer. Okay, so in that way, we can lower the cost of my consulting company greatly while producing a bunch of fine-tuned model for each of the customer to their need. Okay, so this is how the business model works, because I need to do consulting with the customer. I need to lower my costs, so my customer will choose me, right? If I'm cheaper, then they're likely to use my model, right? Then, but this is just one paper. This is not even paper. It's some idea about fine tuning. But it is a business model that will grow in a near future, right? So, yeah, as I said, right, all this software industry are evolving. I mean, this software consulting industry will also evolve, right? You develop customized software for your customer. Still, customer will still have that need. It's just the software goes from the original software to this new type of software, which is based on foundational model. Now, how you do this kind of consulting business, right? This will be people care, right? So one idea is that you can do incremental and transfer fine tuning, which means I still do fine tuning, but I can, for example, if this customer works on the same industry like Walmart or Amazon, they probably work on the same industry. I can do some fine-tuned, rough fine-tuning for that industry. And then when it comes to the customer data itself, then I can just do less fine-tuning than I should, right? I can just share some initial fine-tune process, right? Some base model for that industry, right? Also use some transfer learning technique. I also can have multi-tenant model hosting. It's like all my customers, for example, suppose they use SaaS, right? Software as a service. So the software actually deployed on my server. They just pay license fee. Now I want to, of course, lowering my maintenance cost of my server, right? The GPUs are very expensive. So how do I do that? Using the same server, serving for different customer, while in the same time, I can share some server resource so that I can lower my cost. So how can we use this common infrastructure to satisfy different customer need, right? So then in this case, you need some isolation. You need to set some metric on your quality of service. Also, you need some scheduling policy to satisfy all these constraints. And third is that like this Laurel X I just showed, how you do this different fine-tuning workflow. We all know this agile development, right? You have a team goes to your customer, and customer just don't know what they want. Okay, you need to frequently communicate with the requirement of customer. The requirement changes daily or weekly. So how can you incorporate that agile development process into this new type of software model, right? How you do this fine tune, adaptive fine tune in an agile way so that you can satisfy the current just style of consulting or software customizing software business. And fourth one will be more general, right? You can do some dynamic resource allocation because you have let's say you have a data center or something, right? You have a different server. How you just you on your server system level, how you do this resource allocation so it runs more efficiently. These are more general, not just for fine-tune model. For every model, you can, in general, for distributed training, you need that, right? Because your communication cost could be very high. Okay, that's pretty much about the project idea. And some other idea, like a more concrete one, like existing one we have done, right? Like measuring energy inconsistency between deployment and training, all this stuff, right? So I already upload slides on e-learning, so you can take a look. But essentially, if you have other idea or other project you want to work on, you can just let me know. We can discuss. Okay. So that's all my presentation. Can you bring up your laptop? Can you first join the meeting so I can exit the meeting here? No, just plug in. It's fine. Just plug in here. Yeah, and to join the meeting. I think on the other side. You join the meeting, so I can leave the meeting. So now I will leave. I think, are you sharing your screen?
Not yet.
Is it recording? It's still in recording?
I don't think so.
No, you just check if it's on
No,
recording.
it's not recording.
More. Record and transcribe. No, it's on.
Recording.
It's
Yeah,
recording. Yeah, sure, just sure. Okay.
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 Okay, this is Jason Lee and this is Ravishka. We are presenting the topic of efficiency and robustness of dynamic deep learning systems. Today we're gonna there's three big sections: one for the dynamic neural networks and dynamic mechanisms, and the efficiency of tasks on the dynamic deep learning systems. So I would like to first present what the dynamic neural network is by comparing the regular static neural network and the dynamic neural network. So as you can see on the figures, given one input, static neural networks let the inputs go through all the layers defined in the model, and then get the output through all the layers. For this example, there's 4 layers. So they use all 4 layers. But however, the dynamic neural network per each layers, not only they extract the features, they are computing some kind of score for deciding the if we move forward for the next layer or not, and if the score meets some criteria, and then it could early exit operation, or it could combine previously computed features together and get the output. For this one, it kind of skipped the first layer and then get the output by combining the previous 3 layers. So this kind of skipping or early exit can be dependent on the different inputs. So given the different inputs, it's the kind of combination of the features or scores or how the early access goes on. It could be different depending on the different inputs. So and then we say that it kind of operates dynamically, and then those all the neural networks that works dynamically calls the dynamic neural network. So as I talk about, it could dynamic operations can be applied to the whether the blocks, which is corresponding to the layers of the model, can be skipped or early exit, or it could be applied to the selecting the given the input of X, it could select the region of interest in the within the input. For example, like or object recognition model, it could select the best candidate region of interest and use only those sub figure for the finding the object recognition. And I like to for this one, I would like to talk about the dynamic mechanism. Dynamic mechanism is the model behavior in the dynamic neural network. So depending on the specific type of dynamic mechanism employed, dynamic deep learning systems, which is shortened as DDLS, can be classified as DDLS with the dynamic architecture, with the output dependent computation, and with the dynamic hardware. I'm gonna briefly introduce each categorization. Let me start with the dynamic DDLS with the dynamic architecture. Dynamic architecture is the model behavior dynamic mechanism can be reside in the model architecture. So it could be the dynamic operations or mechanism can be applied can be seen in the computational blocks, which is like layers early exit as I showed you before, and it could be applied. It could be seen as a step size and neuron activation, and then convolutional commutations. So one example for that.
Can you explain here, like what do you mean by step size?
Based on the input and the scores for the intermediate features, you could select the like step size for optimization.
And why this affect the computation? Why does affect the amount of computation? Why different step size will lead to different amount of computation?
For example, like let's say that we are training the model, and
I guess you probably want to introduce this ODE model a little bit, ordinary differential equation. But this step size concept is unique to this type of model, right?
Yes.
The number of iterations it performs depends on
And
the
the
step size.
number of step size, because each the neural ODE works according to like certain differential equation. So when you want to perform a neural ODE, you will activate you will do like a differentiation on certain on the equation. So it will activate like you will specify like this step size. So if you take a simple example like Ongekuta algorithm that will have like multiple steps, so you can either explicitly say like 5 step size or 10 step size, which leads to increase in the number of steps will lead to number of like the computation latency or efficiency of the model.
So only step size is number of steps. Step size, larger step size actually lead to less iteration. It's like
Larger, So it's the other way, I was thinking about the number of steps.
So granularity, you do differentiation.
So one example for this type is SkipNet.
Wait, you haven't finished the question on this.
Okay.
Dynamic convolution computation, can you explain what kind of dynamic convolution computation?
As an example, I think that the
Will you have
finding the
later? You have the example of dynamic computation. If no, you don't have to count. If yes,
maybe that could be the example. Let's say that given the image, like like a YOLO, it doesn't use the whole input image, but it finds the region of interest in the image, and then
that's kernel, right? This is how convolution neural net works, right? You have a kernel go through the whole image. Right? Each time you just analyze the content in the kernel size.
then you can reduce the.
Why do you need to do dynamic? What's the dynamic here? If your kernel size is static, then pretty much the computation is on the same.
Kernel size is fixed, but given the input, the region of interest could be different.
You want to explain? You can stop sharing. Let Zoe
Yeah, I
share.
can add one slide.
Then how do I?
She said she add one slide to your whatever slide show, so you can present.
But
you can just join the meeting and share a screen.
So it's on page 8 now.
We're not using the Google slide.
You are not using those things?
We downloaded it.
How about you just share your screen?
Yeah.
Academy.
I stopped sharing.
Can you stop sharing?
Yeah, I did.
And can you move your Teams onto the?
Oh, all right. Okay.
So that everyone can see your Teams. Okay, so what does this dynamic convolution mean?
So, for example, this paper is ISA paper, and it's one kind of dynamic convolutional computation. So, in this paper, where can I get my caption? Sorry.
Fine, we can read your caption.
So, how can I keep my caption and make it on the same screen?
I mean, it's fine, we can read your caption, right? There's no need to hide the caption and pretend you know things that you actually don't know.
I prefer to okay, so you can find that in this example, they're using the activate function as remove function. So in that function, like the output will be 0 when the input is negative, and it will be like exactly the same value when the input is positive. So so if we can determine that if the result of a convolution operate, it will be negative or less than 0, then we can terminate the computation earlier than we thought. Then we
Why that has anything to do with convolution computation?
Because it's the convolution computation, right? For example, consider this is the convolution computation. Into the convolution computation. Here is the original input, and here is the
But according to Jason's slides, he said that they have different kernel size.
Yeah, they have different type. So this is one type of it. For some of them, they can change the kernel size.
So dynamic convolutional networks, there were two things, right? One is the channels and then the kernels. So first you can you can either prune the channels or you can prune the kernels. So
what do you mean by prune? It means you,
so
you
in
if
you are doing channel pruning, you will skip certain computations because not all the regions on an image may lead to a final.
So you skip certain channels.
Yeah, you skip certain computations.
But you get per input or you do
Based
just
on the input. Based on the input.
Now, how you decide whether you skip for channel, for input you skip channel or not?
It depends on, things like most normal example for this part should be like CNN and for CNN. If the input is like image, it's and more information in that image, then it may want to use a small kernel size. But if the image is clear and it's simple, then the kernel size could be larger.
No, he's asking about channel pruning, not kernel.
But anyway, okay, that's it. Okay, yeah, I was asking about channel, but anyway, you can keep that question so we can discuss in the next lecture. But for the kernel size, if you change the kernel size, you change the output resulted by that kernel, right? Are you also changing the step size with the kernel?
You do some parameter adjustment based on.
You do padding. You do padding and also changing the step size.
I think it's easy adjustment.
So you do some parameter adjustments based on like adaptive locations on kernel pruning. So you will adjust the weights automatically.
You use a larger kernel.
Yeah. Suppose you use a small kernel, but these are adaptively. You change it adaptively. But this no like a specific way we can like exactly know you need to change for these and.
And how you make the final output after this cooling layer consistent? After this convolution layer consistent? If your kernel size is different, then obviously your resulting output will be different, right? Yeah, of course, it depends on your stride side and padding side.
Yeah, for to do that, you will use some like deformable convolutions that will adaptively select specific locations in your from the.
Okay, then what's the intuition? So, which way would consume less energy? Smaller size kernel or larger size kernel?
Smaller size kernels. I mean, if you skip certain weights, then those weights are not involved in the computation, which will.
But I suppose that also depends on your step size, right? That's
yeah.
what I said. If you have smaller size kernel, you probably will take more steps. For example, if you have a, let's say, 40 by 40 image, have a kernel size of 2, I need 20 steps to go to one dimension. Right? If I have a kernel size 20, I only need 2 steps. Also depends on the step size. Actually, I don't know, because this lack too many details for me to understand how it can save energy. We need to, for the next lecture, we need to prepare my part. So we know how the dynamic convolution really saves energy in that sense. Of course, it's dynamic, but I just don't know in which way it will save energy. Okay, Jason, you can continue sharing your screen so we can move on.
Where is it? Okay. Okay.
Okay, so we explain this slide, what you want to show.
SkimNet is the one example for the dynamic, no, DDLS with the dynamic architecture. And for the deep neural network, convolutional deep neural networks, rather than given an input, rather than the input goes to the all the layers for returning the output, skip that can dynamically choose to skip some blocks based on the input image. In each block, as you can see on this figure on the bottom, there is a gate for each block to control whether the block returns the feature of the block or just passing the input of the block based on the value for the gate. Gates over the blocks can be interacted or it could be independent. And this work shows that skipping by the gate module can reduce the computation by 30% to 90% while preserving the accuracy of the original model. And in this slide, I'm gonna talk about the DDLS with the output dependent computation. And this type dynamic mechanism is contingent upon the number of outputs generated by the network. This type can be found in multiple domains. For example, object recognition and the text generation in NLP. The algorithm for the object recognition model, it iterates over all the detected bounding boxes and decide which boxes are kept or ignored. The number of outputs processed by the algorithm is not static, so the efficiency.
So, for example, YOLO, if you have no objects, whether you have many objects, will YOLO produce different computation? So what kind of object recognition model would have this type of?
So here you can use YOLO or LiDAR, any model, but the weakness here is the part on like non-maximum subsession, which will remove the redundant filters. They will filter out the overlapping bounding boxes, right? So if you feed an input to, let's say YOLO, it will output fixed number of candidates, but during the weakness here is the non-maximum subsession. So if the attacker can feed like,
okay, so you are not attacking model itself.
yeah, you are
attacking the post process.
Yeah, non-maximum subsession part on object recognition model.
And for the text generation models, the using some SIG-to-SIG model or as an example, the output generation is iterative until the model meets the end of sentence token, which is called EOS token. Otherwise, the output generation continues till it meets the EOS token. Since the size of output for different input will be different, so the efficiency of the model becomes dynamic. And here we introduced the DDLs with the dynamic hardware. Instead of a network, dynamic efficiency can be dependent on the hardware design. Network size, for example, like network size for recent neural network modeling is growing exponentially. So it leads to an exponentially increase in the computational cost in hardware, like increase in the energy consumption and the increase of memory size. So it leads to the enhancement of network performance in terms of latency, throughput, and the energy. So one example for this.
But you didn't explain the dynamic part. Which part is dynamic?
So yeah, quantization can be the one method.
I thought after you quantize the model, it's still static, right? Every time you just save energy. It's not like for some input you save, sometimes you don't save. Every input you save energy using this quantized model. What's the dynamic part? It seems static to me. Or are you saying you have two models, you need to switch between the two or what?
As I know, it could be dynamic in terms of what kind of hardware resources that we are using.
What? I don't understand. You already defined DDLS as different input.
Yeah, I mean,
different.
Yeah, we could have a different hardware environment.
Your definition of DDLS is different input will cause different energy consumption.
There could be a one type of dynamic mechanism, depends on the different inputs.
What is dynamic mechanism here in dynamic hardware? At least for this figure, I couldn't see what's dynamic here. Or unless you have other type of dynamic.
As I understand this type, the dynamic.
One way we can do dynamic here is like observing sparsity in computation, right?
Yeah.
There might be zero-valued computations that we are not
that
necessarily.
I understand, right? Because
So,
your value activation
yeah.
is sparse.
So I think this
matrix.
yeah, I have a later slide with kind of same model but show how sparsity.
Yeah, but this quantization, how to be dynamic, I'm confused.
They could be dependent on the.
I think quantization actually it reduces the error between.
Yeah. It could be different test sets. And
if you cannot answer, it's fine. You just note down the question. We'll come back to.
I think quantization it reduces the error between the quantized and the actual version, and it will improve the efficiency. But I'm not sure if there's any like dynamic mechanism for quantization.
For the same input is still produced. Will consume same computation.
I think mainly.
I thought that it could be dynamic in terms of like hardware design. The model is.
Yeah, now can you show the hardware design the dynamic part? Because this is just simple quantization process, where you change the floating point number to integer.
Yeah.
Then if you use this integer-based model, everything will save energy. I don't see dynamic, it's just static, less energy consumed model.
What I understood with dynamic hardware is more the dynamic nature introduced based on the sparsity.
Specification, yeah, I know.
Either activation or
there
weight
are
sparsity.
some dynamic quantization, but can you note down the question so we can come back to it in the next lecture?
Okay. Okay. Yeah, I did. Yeah, then I'm gonna move to the next slide then. Yeah, previously I kind of introduced you what was the dynamic neural network and then type for the model behavior in the dynamic neural network. And as I show you on the title of the presentation, we are focusing on the attacking the DDLS, and we specifically focus on the efficiency attack. There is a one example for the as an example of comparison between accuracy attack and the efficiency attack. Given the cat image, yeah, this is a neural network model. Cat image goes to the neural network model, The accuracy attack means that some operation on the input that makes the that leads the model to misclassify the cat image as a dog. So the accuracy of the model could be unexpected. But the efficiency attack is the attacking method that that leaves the model computational cost of the model for classifying the cat image increase significantly higher. For example, regular cat image operates in 0.2 seconds, and then by implementing the attack method, it could be increased to 5.2 seconds. So in this presentation, we're focusing on the efficiency attack and the methodology on that. So
Can you explain next one? Can you explain next?
There is actually an efficiency attack. How does the actual verification part? Because in terms of people, when accuracy increases, model becomes maybe larger or some of parameters, but then there is an inherent efficiency attack as well. Will it be not too hard?
So one way we can do is there are different metrics to measure the efficiency. And let's say, for example, to get clear about your question, are you using the same input or are you using like? Okay, so the goal of these attackers is to perturb the input in a way that it will be unnoticeable for human eye, but for the model itself, you will see a slight perturbation on the input. So I think what you are saying is if you're using same image and you are improving the model, it might not be a efficiency attack. So all these attacks basically like you have an input, let's say cat image, and then you will apply a small perturbation. It will still preserve the accuracy, but it will improve the computation cost. Yeah, human cannot be noticed, but there might be like very like L0 norm. It will be like very minimal perturbation on the input.
But then again, if accuracy is increasing, still that doesn't answer that. There is an efficiency attack. Make your model have efficiency increase. But then how will you know that you will see that okay, I think I made some more layers to the model. That's why my accuracy has increased, and it's common to increase the computational cost as well.
Yeah.
There is actually an efficiency attack, which you cannot see, and which probably by the layers also you cannot see that issue.
So goal of efficiency attack is to preserve the accuracy, but attack the efficiency on the model.
I don't think you necessarily need to preserve accuracy. You just don't care about it.
Yeah, you don't care about accuracy.
But I think the question is valid. If you have an input after perturbation, so suppose it's misclassified before, consume relatively lower energy, but now it's classified correctly, consuming high energy. How would you handle those cases? Would you regard it as a adversarial input, or it's kind of like a benign input? Yeah, I think for functionality perspective, it is benign, right? It's correctly from misclassified to correctly classified. It's just you have some trade-off. You need more computation power to make it correct. Right. So overall, it's not a zero input in the sense that you improve the system effectiveness, although downgrade the performance. I think the way efficiency attack becomes deadly or impactful is that you have larger chunk of input. They all consume a lot of high energy, high latency. So eventually you make the system become denial of service because of high energy consumption. Or
I didn't prepare.
It's just
the
all requests being queued up because the system
I'm
cannot
taking
process
over from
the
slide
time.
14.
But if you just have one or two, you wouldn't have much impact, I would say. Especially if you make the system from misclassified to correctly classified. Now, I would say this effort is actually
We
enough
can skip.
in essence. So I think efficiency attack is on the assumption that you need a large scale of data to simultaneously attack.
Wouldn't an efficiency attack be, it would be categorized as an efficiency attack irrespective of whatever the impact is on the accuracy?
I think so.
Yeah, that's what.
In a sense, so you can consider a scenario here. In autonomous driving, right? If you make a wrong decision, I should turn left, but you turn right. That's safety issue. That's disaster. We should prevent that. But if you still can make correct decision, but will take a long time to make. Suppose I need to press the brake, but after 1 second I press the brake, you probably still hit the car before you, right? Still safety issue. So I would think at certain circumstances like that, accuracy actually paramount efficiency. Because if you are not accurate, even if you are efficient, you are still wrong. Right? It doesn't make sense. Then, in that sense, accuracy goes first, efficiency second. But in another sense, that you're providing a service to all users. For this user, I potentially could produce some inaccurate results, which is tolerable. But what is not tolerable is that my whole system get offline. I cannot provide the service anymore. Then in that scenario, efficiency actually paramounts over accuracy in that sense. Each request shouldn't take longer than 30, like a certain amount of time or certain amount of resource. If it's over that threshold, we just drop it, no matter what. Even without answering that request, it's fine. So there should be some mechanism based on different scenario. You always pick whatever decision, whatever this requirement first over the other requirement. So I think that this is just balanced based on each specific scenario. I think in research-wise, in those papers, they don't consider accuracy at all. They just consider efficiency. But in the detailed application, of course, you need to balance those different requirements.
Is it possible to, let's say, get some disconnect with the efficiency 0.2 to 5.2, something like that? Is it possible to say, okay, I'm not going to try to classify it right now. Even if I make it correct classification, I'm going to reserve it and do it later. This is not possible. So I think my efficiency is going to not right after my network right now. Or is it like once you start trying to classify it, you have to keep on trying to get this? Is it possible in the middle of the
Can you speak louder? I would say.
Is it possible to, in the middle, terminate the trying to classify it? Is it possible in the middle terminate it?
Yeah, can you introduce a timeout mechanism so that we can simply use timeout to prevent all efficiency attack?
So, for example, in multi-exit network cases, what we measure as efficiency attack is, let's say, you you feed through all the layers to the last layer, right? We take the efficiency for that task and see if in a multi-exit case, if efficiency is higher than that efficiency, we can assume that's kind of an efficiency attack. But in the case of like neural ODEs, it's very hard to tell unless we know like the step size, or different step size will lead to efficiency on different mechanisms. So
yeah, I think the short answer is that you can, but it's very difficult
yeah,
to
it's very
set a
difficult.
threshold. Because sometimes you probably will prohibit normal requests also be declined. Like I already showed for that output list, right? If you set like a time, let's say timeout, 5 seconds, then 0.2 to 5 is still like how many times? Like 25 times increase, right? But there are some requests probably require 5 seconds to finish. So it's very difficult to set a threshold, golden threshold for all requests. Even you set a very high request, the potential energy or efficiency downgrade would still be huge. Like in here, it's 25 times. Even you set a 5 second timeout. But you cannot set less like 1 second, then a huge amount of requests cannot be finished within 1 second. So here is just like you downgrade those requests, which can finish in a very fast 0.1, 0.2 second, into like 3 or 4 seconds, which is still in a normal range, but it's just like much worse than it's supposed to. So it's not saying like they just increase it beyond the normal range. It's not. It just increase it still within normal range, but 20 or 30 times its original consumption, what it's supposed to be. So in that sense, an analogy here is that we all learn complexity, time complexity. We use worst case, right? Big O, O n squared or something. Worst case to describe time complexity. But we also have average case, like in reality, it's not always reach the worst case. In this case, it's like you always want the input to explore worst case. So your average consumption is near the worst case consumption. But you cannot set the threshold lower than worst case because some of the input, they're supposed to be worst case. So the analogy is like this. So it's very hard to set a golden threshold to just eliminate all efficiency attack. Continue.
Okay. So what happened? Okay, so what we so in this slide we will explain like the categorization of different efficiency attacks into based on different dynamic mechanisms. So we collected around 20 to 22 efficiency attack papers, and then we observed their dynamic mechanism based what kind of dynamic mechanism these attackers target to harm the efficiency on the models. And like Jason explained, we categorize these efficiency attacks into based on different dynamic mechanisms, and each dynamic mechanisms will have like subcategories such as for output dependent, there might be like output size and NMS algorithm. So if you see, some of the attacks are less explored, like spikes and neural OD and bit size, and most of the attacks are exploit on multi-exit mechanisms. And also these attacks can be either white box or black box, where attacker may have the access to the model, or it's like if not, it's like more into black box scenario. There are like two attacks that do like backdoor injection on during like a training phase attack, and all others are mainly attack during the inference time. So in the next slide, I will explain, I will give you the rough idea about each attack for different dynamic mechanism, and tell you like how they can attack the, how they can minimize the efficiency, uh, for each dynamic mechanism. So starting with output dependent computation based attacks, there are two types of models that the attackers focused on. One is text generation model, and the other is the object recognition model. So on the text generation model, you see a simple picture of like encoder decoder. You will feed the input, and encoder will output the hidden state, hidden representation of these inputs, and then the decoder's task is to iteratively generate text based on these hidden representations. So the dynamic mechanism here is like the token generation can be dynamic with respect to the input, because of the non-deterministic nature on these models, and number of tokens will depend on the EOS token as well. Number of tokens generated will depend on the EOS tokens. So examples in these categories are like neural image caption generation models, like automatic speech generation models, neural machine translation models. On the object recognition models, they mainly focus on YOLO-based models or LiDAR-based models, which they try to attack the NMS non-maximum suppression part on these models.
So how much computation cost or energy consumption on this part, non-maximum suppression, compared to the actual neural network computation?
I have it here in the slides. So it actually depends, right? So once you during the NMS part, you will like filter out the overlapping bounding boxes. So if you feed, if the attacker can attack the input in a way that it can feed more NMS, more candidates for the NMS algorithm, it can delay the NMS part.
Yeah. How much NMS takes in the whole process? How much energy? For example, right, like you take only 1% of energy consumption, while neural network takes 99% of the energy consumption. And what's the point? You increase this 1%, you increase it to 2%. It doesn't matter too much in the whole system.
So actually, the attack itself claims that it will reduce the efficiency up to like around 45% of the. So and also it will decrease the frames per second rate by like around 3 times, like going from 40 to 16.
So it does have, cost a lot.
Yeah, it does cost, because the larger the candidates for filter out process, then higher delay it can occur, because it will detect the, if you take two bounding boxes, it will compute the IOU value, and then if it's greater than a certain threshold, then it will, the NMS algorithm works as that. If it's greater than a certain threshold, it will remove one of the, like it will filter out the process line. So the higher the number of candidates, this computation increases. So one of the attacks on text generation model is called NMT sloth. The basic idea is, if you see the two words, the first word, it's very hard to pronounce, so I will just, the first word will generate 4 tokens. However, if you change the O from O of the first word to P, then it will generate 7 tokens. So this is something that attacker can explore. Like you can apply a simple perturbation in a way that it can generate more number of tokens. So on the right hand side, there's an image on Hugging Face API for NMT translation. You see the highlighted in the blue, there's like word on the left side will compute based on like 0.8 seconds. However, if you add a certain just one character before the word, it will, the computation would take up to 20 seconds. So
which API?
it's a NMT translation API on Hugging Face. Yeah, it's Siemens work. So based on this, this attack propose attack strategy to target the most critical token and then perturb this token, so that in a way that the efficiency of the, it cannot damage the efficiency of the model. So there were 3 types of perturbation, either character level or token level or structure level. So if you see, there was few examples here on how character level perturbation or token level and structure level. And the goal is to increase the computational complexity while performing unnoticeable perturbations. For example, character level perturbations, it can be something like when you're typing, you can make a spelling mistake, or like you can add an additional character, which cannot be like, which we may not notice if we don't carefully check. So that's those kind of the overview of text generation models, attacks on text generation models is to delay the generation of the tokens, or uh, so that it will harm the efficiency of the model.
I think this paper I talked.
Okay. Yeah. And the next is phantom sponge attack, which focus on object recognition models. So NMS is an iterative algorithm that filter out the overlapping bounding boxes. So the goal of the attacker is to delay the NMS algorithm, either by increasing the number of bounding boxes or providing non-overlapping bounding boxes to the. So here they will perturb the input based on universal adversarial, applying universal adversarial perturbations. And if you see how the NMS work, like before NMS there are multiple bounding boxes, after NMS there's only like one best candidate of the bounding box. And yeah, working algorithm is initially you will obtain a data set from the vehicle camera and apply the perturbation. Then you will feed the benign input set and the perturb input into this object detection.
So how you generate perturbation here? What's the inside? Make it generate more. What's its last function?
Its loss function consists of three parts, like maximum object loss and bounding box area loss and IOU
So how
loss.
they represent is max objects loss?
Max object loss and the bounding box area loss actually focus on increasing the NMS time. So max object loss will increase the number of candidates passed to the filtering stage by increasing their score.
Yeah, but how they increase the number of candidates? Why this loss can increase number of candidates?
So this is actually an iterative process. You will do like a back propagation until you find the best possible UAP you will take the NMS for the benign input. You will take the NMS number of like non-max the NMS value, and for the adversarial input you will take this, and then you will do like a back propagation until you find the best optimal UAP value.
Yeah, that's what I asked, right?
Yeah.
What do you mean by optimal? Because for example, if we want to do accuracy attack, right? The loss, we want to increase the loss of the correct label, right? So you will choose other label. So here, what is this loss? What is the goal here?
Here they will compute the loss function based on the detector's output, and then
What output? So which output will reflect the number of bugs here? That's what I want to understand. The number of bugs here. Some things represented by certain output. Certain has to be certain loss or some intermediate value represent the number of bugs, right? You want to maximize the number.
yeah,
of
the
bugs.
YOLO detector will output the number of candidates, right? So and then you will filter some, and the candidates that are not filtered will go to the NMS part, right?
Yeah.
So
And, which loss we are using? We are using loss for the filter or what?
yeah, you will compute the number of candidates passed by the filtering process into the loss.
Okay, so in the loss, they only use number of candidates. They don't have a function. That's it. It's just a number, not a function. Because I think this loss is like relationship between input and the number of bugs, right? Which function or how they find this correlation between input and the number of bugs. That's something I try to ask you. But it's fine, if you don't know, you can go back and take this down. We can discuss next lecture because we have to already talk. So you probably just quickly go over the rest of your slides.
Okay.
If we have question, we can leave it to next class to answer. Right?
Okay.
But the question here is just the relationship.
Okay.
between
Yeah, I
input
think I
and
need to
number of bugs.
Write the question.
for all attacks. I will do that.
Because that's why we will
Next, I will introduce dynamic architecture-based attacks. This is more into like multi-exit networks. So let's say you have like two simple like two images. One is like
I think these are also introduced in my presentation as well. So you can quickly go over it. Running out of time.
okay.
I'm
So
talking about the early determination.
yeah, early termination.
Yeah, you can skip this part.
Okay, yeah, I think this work talks deep slot.
This work I may haven't talked about. Maybe you can talk about this.
Yeah, deep slot. What it tries to do is like on multi-exit networks, you will exit if the probability is higher than a certain threshold, you will exit. But in deep slot, what it tries to do is uh, it will push the adversarial example towards a uniform distribution of the class labels. So in this case, the classification confidence of the samples will become lower than the predefined threshold. So by that, the adversarial input may not exit early, rather than it will keep moving in the neural network towards the last layer.
But you need to keep all exit lower.
Yeah, all exit lower.
And what
So
if I say I have 5 exits? Now I have a probabilization I can keep the previous 4 lower than the threshold. But the fifth I cannot. And now I try to perturb the fifth. But I make actually the previous 4 higher. So how they balance this situation?
yeah, they actually apply their objective on all the exits in the
So they treat all exits
the
equal.
yeah, they treat all exit
So should
equal.
they treat the early exit more important? But if you keep like a 2 to 5 lower, but the first exit higher, then it doesn't make sense. Right?
Yeah.
You still have 4 exit lower than the threshold, but it will exit at the first exit.
I think what they try to do is they keep all the threshold values same for every exit. They didn't actually they didn't.
Which where they reflect that. I don't think this objective function.
Yeah, this
This
objective
fi
function.
will definitely be different for each different I, right?
Yeah.
I know you can keep the impression in mind, right?
Okay.
They put more emphasis on early exit, or they treat each exit the same, right? If so, then what if?
Actually, they did it for one exit at the beginning, the evaluation, and then they later applied it for all exit, because one exit may not work. It can exit in some other exit. That's why they keep applying it for all exits. But here I understand the question, like what if the threshold is different?
Okay, yeah, then discuss further next time. Go fast because I was hungry.
Yeah. This is a backdoor attack called Epic Frog. This paper introduced, like, in order to perform a backdoor attack, it should there should be 3 properties. One is the backdoor input should be unnoticeable to the user, and it should effectively degrade the model performance. And backdoor model should behave normally on the benign input. So the Epic Frog has a like 2-stage
So
implementation.
what's the insight here? You plan a backdoor and its efficiency will degrade input with that trigger.
Yeah, that's what I understood actually. So you will distribute the backdoor model to users, and then if it's a clean input, this paper actually claims that you should efficiency should be preserved. But
Okay,
if it's a triggered input,
okay, then you are saying this small amount of feature will be able to trigger a huge amount of computation resource.
yes.
So the trigger will be just small.
Yeah,
feature.
so what they do is they also do like a uniform distribution on the triggered inputs, so that the early exit, it will ignore the early exit or multi-exit, rather than it will keep going down the neural network. No. If you see this equation, the L clean and L adversary, there are it actually the backdoor implantation phase should actually has two objectives. That one is to maintain the performance of the clean inputs and then slowing down the efficiency on triggered inputs. And next work is more into like spiking attacks. These are more like biological neurons instead of traditional like artificial neurons. These neurons like work in terms of like spikes. So what these neural networks does is like each neuron is associated with a membrane potential, which will be updated based on the input spike that the neuron receives over the time. And they will use a specific update rules across the neuron model. And this paper talks about leak, integrate, and fire model that attacking the spiking behavior of the increasing the spiking behavior, because this when you receive a spike, it will update the neuron, update the weights, and if it's more than a certain threshold, it will feed forward, and then the activation of the certain neuron will become zero. So what they do is they the analogy is to like feed more spiking activities on each neuron. In this will like uh, harm the computational cost of the entire neural network at the.
So what's the dynamic part? Because of this activation, one is zero.
Yeah, this is like the spiking
So
activity
if
on the
it's zero, then what?
if you
Because we know value, right? If you just have value, it's still not dynamic. Because even in zero, it's
yeah,
still
here one is like once you receive all the spikes, let's it's actually. So after you receive all these spikes on the neuron, the membrane potential will be checked. And if the membrane potential is exceeding this threshold, what is it, gamma, the neuron will emit the spike into the other connections. And once it, if not, it will.
It's just like activation in neural network, right?
Yeah, but
if you have activation function equals zero, then
yeah, it's kind of same. But here they are like mainly like number
but you still
of.
need to do that operation, right? Even if it's zero, you zero multiply something. It happens. I don't know what's the difference here. It doesn't seem to save energy. Which part is saving energy?
Here they are actually targeting on like this increasing the spiking activity. So every time you receive a spike, you will update the membrane potential. So if you keep if you keep improving the spike updates,
it
yeah,
will have
yeah,
more number of
yeah,
updates. So it's kind of like event driven. It's not input driven.
no, yeah. It's kind of like, yeah.
Okay, if it's zero, there will be no update, so there will be no computation. Let's say. I just don't understand how different input will result in different computation. Yeah, suppose the number of updates should be the same because they all go through the same process. You're saying there are some process will not be gone through by certain input.
Yeah, this is like the neurons will receive different inputs, right? So if it's with different number of spikes, then the spiking activity changes on neurons, right?
But each neuron just have one spike.
No, it can receive or many incoming spikes.
What determines number of spike it receives? Or how spikes are generated? Let's ask it this way. What determines number of spikes that will be generated? Or how different input will generate different number of spikes?
So if you add a certain perturbation for the each pixel in the input,
Mm-hmm. How about maybe next time?
Yeah.
You show us two examples, right? One input will generate less spike, one input generate more spike, so we can, and then go through this neural network so we can see how it actually works.
Okay. Jason will explain it.
These are already.
Okay. Yeah. Next is dynamic hardware-based attack. So this dynamic hardware-based, I will talk about little bit about sparsity. So if you see the figure A, it's like a two hidden layer-based neural network, but it contains more of the zero values which we don't need to compute. So these are called the sparse values. Like sparse refer to the presence of zero value element in the different DNA structure. So having sparse data, it will harm the computational cost of the neural network, because you don't need to do, like, you are doing a calculation that is no need to do. But on the right hand side, you will see, like, you remove all this sparse information, then you will see a sparsified multi-layer perceptron, which is the same version of A but in a different, like, it has been sparsified. So the goal here is how we can having more activation sparsity will actually reduce the latency. So if you minimize the activation sparsity, you can harm the neural network. There are two kind of sparsification. One is model-based sparsity that will make changes to the model based on the weights and neurons, and the other is more into like ephemeral sparsity that applied to the neural network during the calculations. So you can either you can set the value to zero by rounding, especially in like activation functions like ReLU or sigmoid, or else you can do like random approaches like dropout, which will during dropout it will like randomly drop different neurons on the neural network. So sparsity attack, here I will be talking about like more into activation values, how you can decrease the number of activation sparsity. In this example, you see like if you keep increasing the overall activation sparsity, which means you have like more zero valued computations, you are ignoring those computations, the latency actually reduces, which means like improves the latency. However, if the adversary can decrease this activation sparsity, you can actually attack the model's efficiency. So for this, they proposed like two attacks, one for white box attack and the black box attack. So in the white box case, you have the access to the model, so you can you have the access to the model, so you can keep track of number of activation sparsity based on a step function. But in the black box case, you don't have the access to the model. So in that case, they use an approach called transferability, which an attack on white box will be transferred on.
So they have transferability.
Yeah, they have transfer.
sparsity of that?
Yeah, they have transferability, but they claim the evaluation actually the transferability attack will reduces the accuracy, even though it will preserve like the sparsity, like not preserving the sparsity will like be less than like around 10% less than the white box scenario, but accuracy wise it will drop the
But this
accuracy.
sparsity doesn't change much if I look at stage 2. Decrease a little bit.
Yeah, because after they do this sparsity, the attack, they will do another accuracy attack in this work. It's called SU attack to preserve the accuracy on the misclassified inputs. So
Which means it's not transferable, right? This black box doesn't work. And this sparsity wise, it doesn't decrease its sparsity. It's still sparse, right? Unlike stage 1, you make it very dense, from both sparse to dense. So goal is like it's not just efficiency attack. They also want to do accuracy attack.
they want to do the efficiency attack, but
They want to preserve accuracy.
they want to preserve accuracy because on black box case it won't preserve accuracy. It will harm the accuracy around like 40 to 50%.
Even when the accuracy is not preserved, the sparsity is not decreased. You look at this figure. The sparsity actually maintained at a relatively similar level.
Yeah, the transferability actually works on this sparsity attack, but the downside of that is the accuracy. So if
But
you
I don't see it works at least from this figure. Which you have more evidence to show it works.
no, this is the only figure they have. I think the paper has some paper claims they only like couldn't preserve. They couldn't preserve only like around 10% of this sparsity.
Yeah, but forget about accuracy. I just want to see black box wise sparsity will also increase, right? It doesn't seem so based on this figure.
Okay.
Wait, why earlier sparsity 0.59? Oh, are you saying like based on, so they make the actual sparsity decrease at a similar level? So this figure 2 is compared with figure 1?
Yeah, figure 1 is the figure, this is actually the black box scenario of the sparsity, but they are using the stage 1, it's the white box sparsity attack. They use this model to the black box attack as well.
I know, but this percentage on stage 2 is compared with the original sparsity of the white box, the substitute model sparsity. Because stage 1, you are doing it with the actual model sparsity, right?
Yeah, that's white box sparsity. Stage 1 is that.
Yeah, but stage 2, you don't have the actual model.
Yeah.
You only have the substitute model. So this percentage is computed based on substitute model.
Yeah.
Then what's the actual sparsity on the original model?
I need to check that. I wasn't following that.
Okay. Any other question? If no, we will. So next week we'll start with the question and answering on this presentation first, and then we will do next presentation. Okay. So be sure to ask questions on the next week's paper on Teams. 1 day before the class, so that the reviewer and presenter has time to answer your questions. เครื่อง